Hello students, welcome to Anne's classes. We are doing squares and square roots, chapter 3, exercise 3a, page number 43. We are doing question 4, the first one. Find the smallest number by which 2592 be multiplied so that the product is a perfect square. That means this number is not a perfect square, isn't it? And what is a perfect square? A perfect square is a number whose exact square root can be found. So that means this is not a perfect square, but we have to multiply it with a certain number and we're looking for the smallest number so that this can become a perfect square. So that means the first thing we need to do is find its prime factors. So here let's begin by finding the prime factors of 2592. Let's divide this by 2. Now, when the number is ending in an even number, it's always easier to start with 2. So let's start with 2 here. Now, here 2 ones are 2. Then we're going to 5. 2 twos are 4. What is left is 1. So now it's 19. 2 nines are 18. Again, there's 1 left. So now that's 12. Two sixes are 12. Again, it's ending in an even number, so we can continue with 2. Now let's take 12. Two sixes are 12. Now go to the next number 9. Get a number close to it. Two fours are 8. And there's 1 left, so that's 16. Two eights are 16. Again, even number. Let's continue with 2. Two threes are 6. Two twos are 4. Two fours are 8. Continue with 2. Two ones are 2. There's 1 left, so that's 12. Two sixes are 12. Two twos are 4. Again with 2, let's take 16. Two eights are 16. Two ones are 2. So now, since 81 is not an even number, we're going to stop using 2. We're going to continue with 3. 3 twos are 6. 7, 8. There's 2 left. So now it's 21. 3 sevens are 21. Then continue with 3. 3 nines are 27. Then 3 threes are 9. Then again 3 ones are 3. So now can you see we've got all the prime factors of 2592. So let's write down all the prime factors. Let's count the number of 2's. 1, 2, 3, 4, 5. There are 5 2's. So let's write that. So the prime factors of 2592 has 5 2's. 1, 2, 3, 4 and 5. And let's count the 3's now. We have 1, 2, 3, 4. 4 3's into 3. So 4 times. Okay, now we're going to pair them up. So put them in pairs of the same numbers. So here we have one pair, one pair. Now there's 1, 2 here, but it doesn't have another number to make it a pair. So here we have 2 3's and 2 3's. So here can you see, children, there is one number which is not a pair, doesn't have another number to make it a pair. So that is the smallest number by which 2592 should be multiplied. So when you multiply 2592 by 2, you will get a number whose perfect square can be found. So this is how you find out. Okay, so you pair them up and the number that is left out is the number, the smallest number by which this number should be multiplied. So what is our answer? The smallest number by which 2592 should be multiplied is 2. So our answer here is 2. Question 4, the second one. Find the smallest number by which 12,748 should be multiplied so that the product is a perfect square. That means again this is not a perfect square, but it has to be multiplied with another number so that it can become a perfect square. So we have to look for the smallest number by which this should be multiplied. So let's find the prime factors first. So let's write down 12,748. Now again, like I said, since it's an even number, you can divide it by 2. Let's take 12. 2 sixes are 12. Then take 7. 2 threes are 6. There's 1 left. 14. 2 sevens are 14. 2 fours are 8. Again, you can use 2. 2 threes are 6. Then 2 ones are 2. There's 1 left. It's 17. 2 eights are 16. There's 1 left. It's 14. 2 sevens are 14. Now this number 3187 is a prime number. That means it can be divided only by 1 and itself. No other number can divide this. So we're going to divide this by the same number 3187. So that is 1. So now let's find the smallest number. So we're going to write down this number 12,748. Let's write down all its prime factors. 2 into 2 into 3187. So now pair them up. Now this is in a pair, whereas this number does not have a pair. That means that is the smallest number by which this should be multiplied to make it a perfect square. So we have our answer. The smallest number by which 12,748 should be multiplied is 3187. So this is our answer. Question 5. Find the smallest number by which 10,368 be divided so that the result is a perfect square. Also, find the square root of the resulting number. So again, we know that this is not a perfect square. So we have to find the smallest number by which this can be divided so that the result is a perfect square. So we do the same thing. That is, we find all the prime factors and the number that doesn't have a pair is the smallest number. And after that, we have to find the square root of the resulting number. So let's begin. So the number is 10,368. So let's divide this by 2. So let's take 10. 2 5s are 10. And then 3. 2 1s are 2. There's 1 left. 16. 2 8s are 16. 2 4s are 8. Continue with 2 again. Take 5. 2 2s are 4. There's 1 left. So now it's 11. 2 5s are 10. There's again 1 left. 18. 2 9s are 18. 2 2s are 4. Again with 2, 2 1s are 2. Then take 5, 2 2s are 4, 19, 2 9s are 18. There's 1 left, 2 6s are 12. Continue with 2, the number is 12 now, 2 6s are 12. Then we have 9, 2 4s are 8. And then 1 left, 16, 2 8s are 16. Continue with 2, 2 3s are 6, 2 2s are 4, 2 4s are 8. Continue. 2 1s are 2. There's 1 left. It's 12. 2 6s are 12. 2 2s are 4. Again with 2. Now we have 16. 2 8s are 16. 2 1s are 2. Now we cannot use 2 anymore. Let's use 3. 3 2s are 6, 7, 8. There's 2 left. Now the number is 21. 3 7s are 21. Then 3 9s are 27. 3 3s are 9. 3 1s are 3. So let's write all the prime factors of 10,368. Let's count the twos. 1, 2, 3, 4, 5, 6, and 7 twos are there. Let's write it down. 1, 2, 3, 4, 5, 6, and 7. And how many threes do we have? 1, 2, 3, 4. So multiply 1, 2, 3, and 4. Now let's pair them up. So we'll pair, we have 2's here, 2 again, 2 again. Now here this number 2 doesn't have a pair. So we have 3's and 3's. So now remember children, whenever there's a number that doesn't have a pair, that is the smallest number. That is the smallest number by which this has to be divided. Only then it will become a perfect square. So we've got the first part of our answer. The smallest number by which 10,368 must be divided is 2. So we've got the first part of our answer. Now the next part is find the square root of this resulting number. Now to find the square root of the resulting number, which is the resulting number? This number divided by 2, isn't it? That's what it says, the number divided by 2 so that the result is a perfect square. So the number that is divided by 2, we have to find the square root of that number. So let's write that down. So that will be the square root of 10,368 divided by 2. So let's write down all the factors of 10,368 that we got earlier. So let's write that down. So this will be all the factors. So there are 7 2's there. So 1, 2, 3, 4, 5, 6, and 7. And there are 4 3's, isn't it? 1, 2, 3, and 4. Now this whole thing should be divided by 2. So now here what we can do is, when we divide 10,368 by 2, what we get is 5,184. So what we are getting here is 5,184. So this is the resulting number and we have to find the square root of this. So here first what we can do is we can cancel this 2 with any one of these 2's here. So let's cancel this 2 and one more 2. So now what we have left are these numbers. So let's write down what is left. These are the factors that are left there. So we have 2 into 2. So here I'm counting these. We have 1, 2, 3, 4, 5, 6 2's. Now I've written 2 here. So we'll have 3, 4, 5 and 6. We have cut off 1, 2 there. And then we have the 3's, 4 3's. 2, 3 and 4. So now to find the square root, we have to pair up these factors. We're going to pair them up. As we pair, remember, we must have the same numbers in each pair. So here we're going to remove 1 from each pair. So I'm having 2 into 2, 1 from each pair into 2, into 3, into 3. So now let's multiply the 2's first. 2 2's are 4, 4 2's are 8. So here we have 8 into, let's multiply, 3 3's are 9. 8 into 9, which is 72. That means the square root of the number, the resulting number, which is 5,184, is 72. So this is our answer. Question 6. Find the square root of 0.1764. Okay, so now children, let's be careful here. Now this is a decimal number, isn't it? Now we are going to remove the decimal point and find the square root. So here the question is find the square root of this number. So we are going to remove the decimal point. So that means the number becomes 1764, but it is a decimal number. So we have to give it a denominator which is a power of 10. Now here there are 1, 2, 3, 4 zeros. So here also we should put 1, 2, 3, 4 zeros. So now instead of writing 0.1764, we have made it a fraction 1764 by 10,000. So whenever you have to find the square root of a fraction, you must find the square root of the numerator and the square root of the denominator. So first let's begin with the square root of the numerator. So first let's find the prime factors of 1764. Let's begin with 2. Let's take 17. 2 8s are 16. There's 1 left. 2 8s are 16. 2 2s are 4. Again take 2. 2 4s are 8. 2 4s are 8. And then 2 1s are 2. Now let's divide this by 3. How do we know that this number is divisible by 3? You can add it up. 4 plus 4 is 8. 8 plus 1 is 9. 9 is in the tables of 3. So this number is divisible by 3. So let's begin the division of 441 by 3. 3 ones are 3. There's 1 left, it's 14. 3 fours are 12. There's 2 left, 21. 3 sevens are 21. Is this number divisible by 3? Let's add it up. 4 plus 1 is 5. 5 plus 7 is 12. Yes, it's divisible by 3 because 12 is in the tables of 3. Take 14. 3 fours are 12. 2 left, 27. 3 nines are 27. Now looking at this number, you can make out it is divisible by 7. 7 sevens are 49. 7 ones are 7. So now we've only done the square root of the numerator, isn't it? So let's write that down. Let's write down all the 2's, the 3's and the 7's. So we have 2 and then we have 3 and then we have 7. Now we have to find the square root of the denominator. Now I'll show you an easy way to find when you have 10 or a higher power of 10 like this. Okay, so you don't have to waste your time finding out everything like this. Instead, the square root of 100, remember this children, the square root of 100. What is the number that has to be multiplied twice that will give you 100? 10, isn't it? 10 into 10 is 100. In the beginning, I had told you learn up the square roots of the first 20 numbers. So this is 10, the 10th number. So square root of 100 is 10. That means when there were 2 zeros, the square root had only 1 zero. So here now can you see the number has 4 zeros. Here we have 1 followed by 4 zeros. So let me write that down. 1 followed by 4 zeros. That means the square root I'm going to take a pair of each. So that will be 1 and 1 from each. That will be 100. So now we know that the square root of 10,000 is 100. You don't have to waste your time doing this. Quickly do this in your mind. So here, instead of writing 10,000, we're going to write these factors, that is 100. So that will be 100 into 100. 100 into 100 will give you 10,000. Now we're going to take 1 from each pair. So here we have 1, 2, 1, 3 and 1, 7. Let's write that down. So that is 2 into 3 into 7. And here we're going to take 1 from each here. So that is 100. So now let's multiply. 2 3s are 6, 6 7s are 42. So this is 42 by 100. Now 42 by 100, you can convert it to a decimal number because our question was a decimal number here, isn't it? So let's convert this to a decimal number. We know how to convert it. We write 42, the numerator as it is. We look at the denominator and see how many zeros there are. There are 2 zeros. Because it's division, the point will move 2 places to the left. So the point will move like this. So here what do we have? 0.42. So now we have found the square root of the question that is given to us, that is 0.1764, and the answer is 0.42. So when you have a decimal number, you can do it this way, make it a fraction, then find the square root of the numerator and the square root of the denominator, divide and get your final answer. Question 6. Find the square root of 96 1 by 25. Now this is a mixed number. 96 1 by 25. To find the square root of this mixed number, first step is converting it to an improper fraction. So let's multiply 96 into 25 plus 1. So you will get 2401 by 25. So now let's find the prime factors of 2401. 2401. Now look at this number. This is not divisible by 2 because it's not an even number. Is it divisible by 3? We can add it up. 2 plus 4 is 6. 6 plus 1 is 7. 7 is not in the tables of 3, so it's not divisible by 3. Now let's try with 7. Okay. Now the numbers 24, 7 threes are 21. There is 3 left, 30. 7 fours are 28. There is 2 left, 21. 7 threes are 21. Now let's continue to divide this by 7. 7 fours are 28. There is 6 left, 63. 7 nines are 63. Now it's easy. 7 sevens are 49. 7 ones are 7. So here we have found out the prime factors of 2401, that is 7 into 7 into 7 into 7. And the prime factors of 25 are 5 into 5. You know that, isn't it? Now let's put them in pairs. So here we have 1 7 and 1 7. So let's write that. So that will be 7 into 7. 7 into 7. And here also if we take a pair, there's only 1 5 left. So this is 7 sevens are 49. 49 by 5. That means the square root of 96 1 by 25, which is given to us in the question, is 49 by 5. You can convert this to a mixed number. Divide 49 by 5. 5 nines are 45 and then there is 4 left. 9 4 by 5. So our final answer is 9 4 by 5. The third question here is 0.0169. This is a decimal number. Now we know how to do it when we have a decimal number. So to find the square root of this, we are going to first remove the decimal point. So it becomes 169, isn't it, when you remove the point? And remember to put a denominator where you have 1 followed by the number of decimal places here. 1, 2, 3, 4. That means zeros followed by 4 zeros. Okay, now we already know the square root of 169. If you have learnt all square roots from 1 to 20, you will know that the square root of 169 is 13. And we also learned to find the square root of a number like this, 1 followed by 4 zeros. Remember, I said 1 followed by 4 zeros. Now take 2 zeros, pair it up And so what is resulting is 1 followed by, take 1 0 from here, 1 0 from here, so that becomes 100. So 13 by 100. So the square root of 0.0169 is 13 by 100, or if you convert this to a decimal number, what do you have? 13, and denominator has two zeros, and since it's division, the point will move two places to the left. So it will move like this, and the point comes here, and you have a 0 here. So the answer here is 0.13. This is our final answer. Question 7, evaluate. Now we're going to divide, we're going to find the square root of 14.4 divided by 22.5. As you can see, both are decimal numbers. So what are we going to do? We know that if we have to remove a decimal point, we have to divide it by 10 or a higher power of 10. Now let's take 14.4. Now I'm going to make it a whole number, removing the decimal point. Now I need to divide this by 1 followed by 1 0, that is 10, because after the point there is one place. Okay, now divided by 22.5. So divided, let me put it this way, divided by 22.5. I'm going to remove the decimal point. So this also should be divided by 10, because after the point there is one place. So only 1 0. Now this division, these are two fractions. I'm going to change it to multiplication, because that's how we do division, isn't it? So here, let me write that. So this one remains the same, 144 by 10. Division will change to multiplication, and we write the reciprocal, 10 by 225. Now I can cancel the two tens, this 10 and this 10 I can cancel. So now the square root that I need to find is the square root of 144 by 225. Now, if you have learned the squares and square roots of numbers from 1 to 20, you will know that the square root of 144 is 12, and the square root of 225 is 15. You can do the prime factor method by finding all the prime numbers and pairing it up. But if you have learned from 1 to 20 by heart, it's going to be very easy. You can quickly do this without wasting your time by finding all the prime factors. Now we have 12 by 15, which we can reduce to the lowest term. Both are divisible by 3. 3 fours are 12 and 3 fives are 15. So here we have 4 by 5. Now since we have decimal numbers here, we can convert this also to a decimal number, or your answer can simply be square root of this is 4 by 5. Now let's convert this to a decimal number. So 4 is divided by 5, 4 is smaller, so we put a 0. Now to continue with our division, we can put a decimal point and carry the decimal point on top and put a 0. Now after the point, we can put any number of zeros. Now take your number to be 40. 5 eighths are 40 minus 0. So now what do we have? We have 0.8 as our quotient. So our answer here is 0.8. So we have found the square root of 14.4 by 22.5 to be equal to 0.8. So this is our answer, 0.8. Next question, we have to find the square root of 0.225 by 28.9. So we're going to do it the same way. So here, let's do this. We're going to remove the decimal point. So 225 by, so this will be, let me write that down, 225 by 1 followed by how many zeros? 3 zeros, because there are 3 decimal places here. 1, 2, 3. Now divided by 28.9. So that remove the point 289. Since there's only one decimal place, you have to put only 1 0. So that makes it 10. Now decimal, remember these are two fractions. Division, we're going to convert it to multiplication. 225 by 1000. Division changes to multiplication. We write the reciprocal, and now we have this. Now we can cancel. I can cancel 1 0 there and 1 0 here. So what do I have now? So now what is left is 225 by 100 into 289. So we have to find the square roots. So again, to find the square root of 225, you can use the prime factor method. For any of these numbers, you can use the prime factor method. But if you have learned your prime squares and square roots of numbers between 1 and 20, this is going to be very easy because we know that the square root of 225 is 15, square root of 100 is 10, and the square root of 289 is 17. Okay, can you see how much of time has been saved when we know our square roots from 1 to 20? So you don't have to waste your time finding out all the prime factors and then pairing them up and finally getting this. Okay, so we have 15 by 10 into 17. So since this is multiplication and division, we can cancel. I can cancel 10 and 15. 5 twos are 10, 5 threes are 15. So this is now, in the numerator, we have 3. In the denominator, 2 into 17, which is 34. So we have found the square root of 0.225 by 28.9 to be 3 by 34. You can even convert it to a decimal number if it is required. So final answer here is 3 by 34. Square root of 25 by 32 into 13 by 18 into 0.25. So now let's go slowly. Let's write this down first. So this becomes the square root of 25 by 32. Leave it as it is. Second one, convert it to an improper fraction. 18 twos are 36. 36 plus 13 is 49. 49 by 18. Then the third one is a decimal number. We're going to remove the decimal point. So that becomes 25 by 1 followed by 2 zeros because there are 2 decimal places. So that is by 100. Now here there are some numbers where we know the square root of. At the same time, there are certain other numbers where there are no square roots. They are not perfect squares. So we are going to find all the prime factors of all these numbers. Some of the numbers we already know. So let's write down the prime factors now. Now 25, what will the prime factors be? 5 into 5, isn't it? 5 fives are 25. 49, 7 sevens are 49. Again 25, 5 fives are 25. Now let's find for 32, let's find the prime factors. 32 divided by 2, 2 into 16 is 32. Then again you continue, 2 eights are 16. Then we have 2 fours are 8. Then 2 twos are 4 and 2 ones are 2. As you can see, these two have formed pairs. We have an extra 2 here. That means 32 is not a perfect square. Okay, so whenever you have an extra number which doesn't have a pair, remember that number is not a perfect square. So let's write down the 5 twos here. 1, 2, 3, 4 and 5. Now next number here, we finish with 32. We have denominator 18. Similarly, just like this, let's find the prime factors of 18. 18, this will be 2, 2 nines are 18, then 3, 3s are 9, 3 ones are 3. So here also let's write down this 1, 2. So let's put that 1, 2 there and we have 2 3s. Then the next denominator is 100 and we know the prime factors of 100, 10 into 10. 10 into 10, these are factors, not prime factors, but we can write them down. We know that 10 into 10 will give us 100. Now we are going to pair them up. So here, let's pair up the numerator first. So here we have one pair of 5, one pair of 7, another pair of 5 here. So let's put all the 5s together. So 5 into 5 into 7, I'm taking 1 from each pair. Similarly, in the denominator, we're going to first pair it up. So here we have the pairs and we're going to take 1 from each pair. So from this pair, we have 1, 2, then 1 more 2, 1 more 2, and then we have a 3 and a 10. Now we have to just multiply these. Now, if there's something that we can cancel, let's do it. We can cancel 5 and 10, isn't it? So let's cancel that. 5 ones are 5, 5 twos are 10. So whenever you cancel, your work becomes easier. So multiply the numerators. 5 into 7 is 35. Now in the denominator, what do we have? 2 twos are 4, 4 twos are 8, 8 threes are 24, 24 into 2 is 48. So we now have our answer. 35 by 48 is the square root of what is given to us in the question. Next one. So here also we have mixed fractions. So first thing we have to do is convert them to improper fractions. So let's do that. So here we have 1 4 by 5. So 5 ones are 5 plus 4 is 9. 9 by 5 into, now 44 into 14 plus 21 is 637. So work that out carefully. You need to get 637 by 44 into 55 into 2 is 110 plus 7 is 117 by 55. Now we have to find the prime factors of all these numbers first. We have to find the prime factors, so let's do that. Now let's begin with the first number, 9 by 5. Now here, let's write that down. So 9, we know the prime factors of 9, 3 into 3. 3 into 3 and 5 is 5 by itself. Now we have to find the prime factors of 637. So let's do that. 637. Now, as you can see, 63 and 7 there. That means this is divisible by 7. 7 nines are 63, 7 ones are 7. Now let's divide this by 7 again. 7 ones are 7, 8, 9. There's 2 left. 21. So that's 13. So here 13 itself is a prime number. So let's write 13 ones are 13. So now the prime factors of 637 are 7 into 7 into 13. Let's write that down. So this will continue. So this is 7 into 7 into 13. Now we have 44 in the denominator. Let's find that. So 44, let's divide this by 2. 22. Then again divide this. 2 11s are 22. 11 is a prime number, 1. So 2 into 2 into 11 in the denominator. So let's write that. 2 into 2 into 11. Now let's go to the next one, that is 117 by 55. Let's find the factors of 117. Now, is this divisible by 2? No, it's not divisible by 2. Is it divisible by 3? Let's add it up. 7 plus 1 is 8. 8 plus 1 is 9. Yes, 9 is in the tables of 3. So let's take 11. 3 threes are 9. 10, 11, there is 2 left, 27. 3 nines are 27. Continue to divide this by 3. 3 ones are 3. 3 threes are 9. We have 13. 13 is a prime number. 13 ones are 13. So prime factors of 117 are 3 into 3 into 13. Let's write that. 3 into 3 into 13. In the denominator, we have 55. So let's take 55 and see. Divide this by 5. 5 11s are 55 and 11 ones are 11. So 5 into 11 in the denominator. 5 into 11. So we have split them up all into their factors. Now we see if they have pairs. Okay, so we have 3 into 3, 7 into 7. Then we have a 13 here and a 13 here. So this can form a pair, and 3 and 3. Now here we have a 5 and here we have a 5. So they can form a pair. 2 and 2 here, 11 and 11 here. Let's keep all the pairs together. So let's write that down. All pairs together. So we have 3 into 3 into 7 into 7 into 13 into 13 into 3 into 3. So we've put them all together. In the denominator, let's begin with 5. 5 into 5. Then we'll put 2. 2 into 2. And then we have the 11s. 11 into 11. Then you can check to see if there's anything that you can cancel. If you can't cancel, then we just go ahead and look out for the pairs. So let's take out one from each pair. So we're going to remove one from each pair. So let's see what we get. So here we get 3 into 7 into 13 into 3. In the denominator, we have 5 into 2 into 11. So this is what we need to multiply. Now let's multiply. We can multiply the 3's. 3 threes are 9. 9 into 7 is 63. Now 63 you can multiply into 13. And when you multiply 63 into 13, you will get 819. So what do we get? 819 here. In the denominator, 5 twos are 10. 10 into 11. 10 into 11 is 110. So in the denominator, we have 110. So what do we have here? 819 by 110. you can convert this to a mixed number. When you convert it to a mixed number, you will get 749 by 110. So you have to do your division, divide 819 by 110, and you will get the 749 by 110, which is the square root of this question. So children, we will stop with this for now. In our next video, we will continue with the remaining questions. Thank you, children.